Hello everyone, welcome to In 5 Minutes. In this video clip, we'll discuss one more problem on supermesh analysis. The question says find all branch currents using mesh analysis. So if you have to find out currents in each and every branch, but we have done a similar question before also. If I want to find branch currents, before that I'll have to obtain mesh currents. So I'll obtain mesh currents first because we are asked to use mesh analysis. So once we get all the loop currents, all the mesh currents, then we will find out the branch currents one by one. Now in this case, since we have to apply mesh analysis, let us first identify all the meshes that we have. Now it is very clear that there are total 4 meshes, 1, 2, 3 and 4. Total there are 4 meshes available. Now with 4 meshes, otherwise the question can become very complicated because there will be 4 unknowns and there will be 4 equations to be solved, which is very difficult to do. But here you can see that there is a current source of 15 amperes between the 2 meshes, so you can't apply KVL equations in individual meshes. We'll have to consider super mesh. Similarly, there is current source of 15 ampere between 2 meshes. Again, it doesn't matter whether there is any resistance or not in that branch of the current source. As long as there is a current source between the 2 meshes, we have to apply supermesh analysis. So basically there will be 2 supermesh that we'll have to consider. But before we consider supermesh, we will quickly define all the 4 currents in 4 meshes. I'll call this as I1, I'll call it as I2. This is I3 and this is I4. So let us start from mesh 1 and mesh 2. You can see I can't write individual KVL equations because there's a 15 amperes current source which is being shared by both the meshes. So we will have to consider super mesh analysis. So this is how I'll define my first super mesh. So starting from 20 volts, let's see how the KVL equations will look like. So KVL in super mesh 1, 2. So I'll start from 20 volts. I'm going from negative polarity to positive polarity and hence there is rise in voltage. So it is 20. Next is 2 ohm resistance. Through this 2 ohm resistance, the current is I1 flowing towards right and I3 which is flowing towards left. So if I take a current flowing towards right, which is same as I1, then that current will be nothing but I1 minus I3. So I can define current flowing towards right hand side as I1 minus I3. So because we are also traveling in the right hand side direction, the drop will be negative. Minus 2 is the resistance and current we have taken is I1 minus I3. Next, instead of coming down, because we are applying super mesh analysis, I'll go towards 1 ohm resistance. Once again, through 1 ohm resistance, there are 2 currents flowing, I2 towards right, I4 towards left. So I will define a current which is flowing towards right, and because I've taken right hand side direction, which is same as direction of I2, this particular current will be I2 minus I4. So traveling towards right, drop will be negative because we are in the direction of current, so it will be minus. Resistance is 1 ohm and the current is that we have taken is I2 minus I4. Next, there is one more resistance which is 3 ohm, but it is simpler compared to the previous two because the only current through 3 ohm resistance is I2. I'll be traveling in downward direction, so does I2, and hence this will be negative drop again, so minus 3 I2 equal to 0. So let's simplify this. First I write down I1 term and minus 2I1. Next I write down I2 term, which is minus I2, then minus plus 2I3 minus plus I4 plus 20 equal to 0. What I'll do is I'll send all these I1 terms on the other side, keep 20 on one side. So I get 2I1 plus I2 minus 2I3 minus I4 equal to 20. So this is one equation. Now quickly you can see that because there is a current source of 15 amperes between the 2 meshes, the next equation that I can write will be 15 amperes, which will be difference of I1 and I2. Current through this 15 amperes will be I1 in downward direction and I2 in upward direction. So the 15 ampere has to be difference between I1 and I2. This is what we did in the previous question also. The question is whether 15 will be I1 minus I2 or I2 minus I1. Please take a guess. Because the direction of 15 amperes is downward, which is same as direction of I1, it will be I1 minus I2 equal to 15. So this is my first equation. I'll just call it equation number 1. And now I'm saying that from 15 ampere current source, we get I1 minus I2 equal to 15. So let me call this as equation number 2.